Welcome to Computer Science 4300. This is the first lecture. We're live streaming this on Twitch this year, so if you see this on YouTube or if you've downloaded the VOD somewhere, this is being live streamed on Twitch. So if you see me referencing the chat or any students asking questions, that's what this is that this is being live streamed. So this is Computer Science 4300, Intro to Game Programming. I'm super excited to teach this after a long summer of just sitting around. It's actually nice to be able to pseudo talk to people again. I'll get into all the info here in a second. First, what I'm going to do is I'm just going to load up my website. So this is my website here. It's linked on D2L and in the course syllabus. So it's just mun.ca/Dave Churchill. You can also type !course to get all the info about the course if you're in the Twitch chat. So if you go over to the teaching part here, let me just paste this link for people. This is where all my relevant teaching information is. So here we have the 3 courses that I'm teaching this year. So I'm teaching COMP4300, COMP4300, which is this course, and COMP6980. Each of these courses is going to have a schedule. So we have a spreadsheet, which is going to be your sort of Bible for the course. So for example, over here, if I open the course spreadsheet for 4300, then I get to this page. So let me just make this a little bit bigger. So this is the course spreadsheet. I have this for all of my courses, and it's basically the diary of everything that we're going to do in the course. So over here on the left, you can see all the dates of all the lectures, what day of the week they are, and essentially what we're going to be doing for the rest of the course on each day. We're also going to see what links here to be able to view the slides or view the lectures online. So before I continue, I'm just going to show you an example from last term. So this was the course spreadsheet for 4300 or 4303, which is another course that I'm offering in the winter. So this is what it will look like eventually as this course fills up. So for example, you'll be able to just see, okay, I wanted to look at the space representation slides. Well, I can just go here and open those right away. Okay, so they're all there. They're stored on my website. You can view the VODs on Twitch or on YouTube, so you'll be able to instantaneously go to that lecture. And a lot of my lectures will have timestamps and stuff, so you can skip ahead to the parts that you need refreshing on, etc. So this is what our website will look like. It'll be populated with a bunch of links. And also, if you really want to get the highest possible quality for the lectures, you can download the individual video files for the lecture. So officially, this course is being given via pre-recorded lectures, okay? So you'll have them on YouTube, you'll have the Twitch VODs, and you'll be able to download them. The reason that I'm not putting the recordings on D2L is that D2L caps the resolution at 720p and has like a smaller file size capability as well. So they're not on D2L because of that. I want you to get the full like 1080p resolution that I'm recording at, and so you can view them in any of these 3 ways. So yeah, the course is being delivered officially, officially through the pre-recorded lectures. So they'll be there for you to watch. And as such, tuning into Twitch or YouTube is completely optional, okay? It's great if you come hang out and ask questions and stuff, but essentially my live stream for these lectures is just you being able to watch me live while I record the pre-recorded lectures, okay? So that's just sort of a little legal thing because, the university doesn't officially support Twitch as a platform, and so I had to make the Twitch part of things completely optional, and that's the way that I did it. So yeah, the official way that you should take this course is through the pre-recorded lectures. I recommend watching them on YouTube because it's easier to be able to jump around, but if you want, you can download the lectures as well. Over here, I've color-coded things a little bit. So in blue in the schedule, that's going to be when the assignments are given out. In green, that's when we have no lecture on those days. However, recently, the university has made September 30th a holiday, and so there will officially be no lecture on September 30th. However, the video will be there for you on September 30th. So the university did a really weird thing where they're like, hey, this Thursday is a holiday, but we're going to move classes to Saturday. So we gave you a holiday on Thursday, but took away your day off on Saturday. So what I'm going to do is just the videos will be there on Thursday. You can wait until Saturday to watch them if you want, but they're there on Thursday, okay? And unfortunately, that's a day when an assignment is given out, so watch them sooner rather than later. So that's just a quick aside that this Thursday, September 30th, is a holiday, but since we're online and it's pre-recorded lectures, it won't really matter much for us. You can see here that you'll have a lot of time to do the assignments, so at least 2 weeks for every assignment except the first one. The first one is super easy. It's basically just, can you set up Visual Studio, C++, SFML, that sort of thing. Okay, so that's the course spreadsheet. That's all you really need to have open for the course, except the official announcements and assignment submissions and stuff are on D2L. There is also a class Discord server, so make sure that you're on the Discord. Again, it is optional, but there'll be lots of discussion and stuff going on the Discord server. And please don't post links to that in the chat because that is for students only, because I don't want a bunch of people trolling the Discord server. Okay, so yeah, for really important messages, see D2L. For assignment submissions, all assignment submissions will be done on D2L. Project submission will be done on D2L. It's just I made this spreadsheet so that this is your whole course life and you can view it whenever you want. And that's there for my other courses as well. So let's go into the syllabus for this course, and I'll go through this before we get into a few slides. All right, and feel free to ask questions in the Twitch chat while I'm going on. I'll read out the questions and then I'll answer them in case anything was unclear. So yeah, Memorial University of Newfoundland is where this course is being taken. It's a computer science course. The number is 4300, and the course is Introduction to Game Programming. We go into a little bit beyond just an introduction. I don't know how you could just do an intro in like a 4-month course. We go into some intermediate stuff, I would say. And this course is going to be done in C++, but if you've never done C++ before, don't be worried. The next 2 lectures are all on C++ and getting you up to speed with all the C++ that you'll need to know for this course. So in this course, you're going to go from possibly not ever having looked at C++ before to writing an entire 2D game engine in C++. Someone just asked, if you are not a student at the university, can you still take the course, but you won't grade assignments? So that's a good question. Officially, the only people who are taking the course are the students. All of the lectures are available to everyone, but the assignment files will only be given to students. So if you're not enrolled at the university, you can't do the course. That's a little bit unfortunate, but that's because these assignments take me weeks, if not months, to make, and I cannot do new assignments every year. So I can't have these assignments leaking to the public because that would completely ruin the course for future generations. Someone said that the links don't work yet. The links, so for example here, the Google Sheet link and the PDF link, but the lectures, there are no lectures yet. So as soon as this lecture is uploaded to YouTube, this lecture link, that will link to a playlist that will have all the lectures for this course as we go. Okay, so let's go back here. So again, the course website, technically the course website is, if you click on this link, you're just taken to this directory and it has some files there. So I call that the course website, but the course website is not required because all of that is linked from the spreadsheet anyway. Let's go back. So the course objective. This is a course for students interested in learning the fundamentals of game programming and game engine architecture. Topics include an introduction to vector math for games, rendering, animation, artificial intelligence, collision detection, game physics, and user interfaces. Students will be writing fully functional games using the C++ programming language and the SFML graphics library. So here's the course outline. So this is a complete list of topics that we're going to be doing, and these aren't necessarily in order of instruction. I just wanted to be able to group them. Excuse me. So first, we're going to do an introduction to C++ and SFML. So we'll go over, this is actually C++ 17. So C++ 17 syntax, semantics, and a bit of STL stuff like containers like vector and set and file in and output. C++ compiling, linking, and make files. That's how you're going to build your programs. SFML. So SFML is a simple and fast multimedia library, I think it's called. It's basically how we're going to render stuff. If you've ever done any C++ stuff in the past, you know that drawing to the screen is the hardest thing in C++. So this is the only external library that we'll be using. I'll go over an entire lecture of SFML, but essentially it's just the thing that lets us load PNG files and draw them to the screen, okay? Because we don't want to be writing all that stuff by ourselves. And it's a 2D graphics library. We'll be talking about some graphics primitives, drawing things, input handling, etc. Then we'll go into low-level 2D game engine design and implementation. So we'll talk about the game engine layout and architecture, basic game engine main loop structures and tick rate, game states and state machine architecture, asset loading, memory management, sprites and animations, some basic rendering. We'll talk about basic shaders. Someone is asking about OpenGL in the chat. SFML is actually based on OpenGL. And trust me when I say that you do not want to be implementing a game from scratch in OpenGL in a course, because you will spend the first month trying to figure out OpenGL. So this is basically a bunch of helper functions on top of OpenGL that let you just instantaneously get stuff up and running. This is not a graphics course. It's a game programming course, so we want the graphics to be as easy as possible. A big part of the course will actually be talking about ECS, so entities, components, and systems. We'll talk about an overview of what ECS is, architecture and design around ECS, how we design the classes, the structure, the memory management for ECS, systems for implementing gameplay mechanics, and memory pooling strategies on top of ECS. We're also going to go into some basic physics and math for games, so vector math, and some class implementations, kinematics, so we'll talk about position, velocity, rotation, acceleration, projectiles, gravity, all that kind of stuff. Collision detection and resolution for basic shapes, and line segment intersection. Also, of course, we got a lot of gameplay programming, so very, very basic artificial intelligence. If you want a more advanced game AI course, that's 4303, that's being offered in the winter. Entity interaction, a little bit about dialogue, difficulty settings, game configurations, game event triggers, items, inventory, weapon systems, all this kind of stuff, game programming tools, we'll do a level editor, and all of this is going to be done completely from scratch. So the textbook, I hate having required textbooks because I don't want you to spend more money than you have to, and let's be honest, you're just going to use Stack Overflow anyway. But here are some recommended textbooks if you really are a complete beginner with C++ and you want as much help as possible. You can go through these books. However, they're not necessary. The lectures and a little bit of practice on your own should be fine. There's going to be 2 lectures per week on Tuesday and Thursday. So let me talk about that really quick. So here is the Memorial University schedule. So there are these time slots. Like, for example, this time slot is from 2 p.m. to 3:30 p.m. or 3:15, and it's in slot 19. So here is my current teaching schedule, which is really unfortunate because it is impossible, physically impossible for me to give these 2 lectures right in a row. So our class is from 2 to 3:15. Then I teach 3200 and 6980 from 3:30 to 4:45. It's really strange, actually. When you're lecturing live online and you don't have students looking at you, there's very little room for breaks in talking, and so lecturing for 3 hours straight, while also having no break in between to start and stop the stream and save the VODs and all that kind of stuff. It really is quite physically impossible for me to do 2 lectures in a row all term. So what we're going to do from now on, and this has already been explained on D2L, is that the live lectures for this course from the next lecture all the way through the term are going to be here and here. So they're going to be on Monday and Wednesday evenings. Those are the live lectures. Now, it really doesn't affect you that much because the videos, the recorded videos, will be available for you to watch at the standard class time. Okay? So all that's changing is when I do these live recordings of the official pre-recorded lecture. So this will not affect you in the slightest if you weren't tuning in live anyway, but it will. They're just moving to Monday and Wednesday, so I can do. So I have a little bit of a break to make this physically possible. Okay, so if you type !schedule in the chat, or you go to my channel /schedule, this change has already been reflected. Okay, so you can go to the schedule. It shows Monday, Tuesday, Wednesday, and Thursday, and the times will be in your time zone, so you can tune in and watch those live if you want. However, as I said before, all the videos are linked from the class spreadsheet, so you can just go to the spreadsheet. All right, and they will be there for you to watch. Now, someone might ask, like, hey, why didn't you move it the same day and just move it into the evening on the same day? Well, the reason is because I wanted to move it the evening before so that the lectures are ready on time rather than have the lectures be late, okay? So that's why I'm doing it the night before so that you can have the recorded lectures during the normal class time. So yes, the official lecture videos will be there on Tuesday and Thursday at the exact same time, so you can watch them during the normal class hours. If you had already scheduled that as part of your life, it won't make much of a difference for you. So the evaluation of the course, we're going to have 4 assignments, technically 5 assignments, but we're going to make 4 separate games. The intro to C++ and SFML isn't exactly a huge deal. That's just you getting used to C++ and setting up the environment. We're going to make our first game with ECS as assignment 2. That's going to be like a Geometry Wars clone. Then we're going to make a Mario type clone. And once I get into the slides, I'm going to show you all of this stuff. And then we're going to make a Legend of Zelda clone for the 4th assignment. And then you will have a final game project. So the assignments are split up semi-equally, and they are worth half of the course. And you can do the assignments and submit them in groups of up to 2 people. So you can do them by yourself if you want, but I highly recommend getting a partner because the assignments were designed as enough work for 2 people, okay? If you're super keen or super protective, you do not have to do them with a partner, but I highly recommend you do them with a partner. The final game project is going to be done. Now, I haven't completely decided on this yet, whether or not it's going to be groups of up to 4 people, but for now, I'm going to say groups of up to 4 people. So you can sort of combine 2 groups from the assignments and make a mega game for your final project. And we'll have an entire lecture about the project, so don't worry about that right now. Start thinking about partners for the course, and if you don't know anyone in class, I am going to release a spreadsheet. I'll link to that on our spreadsheet where you can put your name down. And actually, since the spread, I'll put a link to the spreadsheet on the Discord and on D2L, and then you can put your name down and you can find partners in that way. So finding a partner shouldn't be a problem. Here's something really important though. Due to the unique marking structure of this course, you must pass the final project to pass the course, okay? So, with assignments being worth 50% of the course, you cannot just do the assignments, get 100, and then do nothing for the final project, okay? That is why this rule is here. You have to do, it's all about game programming, so your final game has to matter, right? So you must get at least 50% on the final game project to pass this course. So if your grade on the final project is less than 50%, then your overall course grade will be equal to the mark that you received on the final project. So if you get a 0, if you don't do the final project at all, if you get a 0, you get a 0 in the course, okay? However, please don't worry. If you get like a 40, this happened in the last course, someone handed in a final project that didn't even compile. okay? And you're obviously not going to pass if it doesn't compile, but I talked to them. They had some issues with group mates and COVID and stuff like that. So there's always going to be, if there's a legitimate reason why you weren't able to get the project done on time, we can extend that deadline, and we'll talk about that for health reasons or whatever. So, and also, if you get like a 45, you know, you're not going to fail the course. We're going to get you like a little bit of supplement. I'll say, okay, go change this in the project and resubmit it, and you'll get that 50, okay? So unless you really screw up on the final project, you don't need to worry about this. It's just to make sure that students actually put work into the project. And, this is not the full version of my thing. Give me 1 second here. Okay, so I need to re-upload this because that wasn't the full version of my syllabus. So I'll put the full version of the syllabus up there. Here's the thing that's missing from that. So I have to put in this COVID notice. Oh, geez, there are no... Okay, that was wrong. Don't worry. There's no exams for this course. This is for 3200, so I messed things up on this version of the syllabus. So we'll skip that. COVID doesn't matter for this course because it's all online. Okay, so I officially have to state that the sort of recovery policy for this course, if COVID flares up and the university has to close, we have no recovery policy because there's no in-person evaluation for this course. Academic misconduct. So I hate having to talk about this. I really hate having to talk about this. Society hates having to have police. Right? If there was no crime, there'd be no police. But I have to talk about cheating because every year there's always 2 or 3 people who try and just cheat their way through the course. I take academic misconduct very seriously, okay? Especially for remotely delivered courses. If you're trying to take advantage of the fact that we're not in person to cheat your way through the course, it's going to be a real bad time for you. This is like... I'm not a very serious person, but I am very serious about that. So anyone found cheating in this course will receive the harshest possible academic penalties. And I mean, like, not just 0 in the assignment, okay? You may not pass the course if you're caught cheating in any way whatsoever. So academic misconduct for this course includes, but is not limited to, the following things. So believe it or not, people outright cheat. I have had people pay to have their assignments done online terribly. And if you cheat, I can smell it. Trust me. If you hand in an assignment that was done by someone outside the course, I can smell it and I can detect it because the code is way different than what I've been teaching. The style is way different. Trust me, it would be very difficult for you to get away with cheating in this course. And when we talk about the first assignment, I'm going to tell you why it's going to be so hard to get away with cheating. Please don't. I hate having to say this, but it's necessary. And people don't know what cheating is. Even though you have to sign something at the university and go through some weird course about academic misconduct, here is what I consider cheating. Handing in any material for evaluation that was done outside you or your group. So if you got another group's work and you submitted that, or if you got a friend to help you and you submitted that, or if you copied off of Stack Overflow and you submitted that, or if you paid someone and submitted that, I know 99% of you are rolling your eyes right now, but it happens, so I need to talk about it. Obtaining solutions from any non-class source, such as outside of your group, previous course offerings, Stack Overflow, etc. So if you obtain solutions from a previous offering of the course, I have all of those solutions already, okay? So everyone who submitted assignments from last year, I have a huge directory of every assignment that has ever been submitted to this course. When you submit your assignments, they all go into that directory, and then we run anti-cheating diff tools to see whether or not you have copied and pasted anything from any of those previous assignments. And changing the variable names doesn't work. Changing the white space doesn't work, okay? If you have copied and pasted code or handed in someone else's files, I'll know. It's trivial to detect that sort of cheating. Now, when it comes to Stack Overflow, I will make this exception. Let's say, for example, there's a topic that's not taught in the course, like some crazy low-level optimization or AI technique that you want to put in your game. You can go online for the bonus stuff and look at solutions for that. But if I've told you, please implement this specific thing, do not go online and get solutions for that, okay? So for example, if I said, implement these bounding box collisions, implement those from the slides. It's going to be way easier because my slides are better than Stack Overflow anyway for those particular things. But if you're making a full game, for example, if you want to write a shader that makes the whole screen wobble or something like that, you can absolutely go online and get those bonus things from online. However, please, in your assignment, just quote in your comments where you got that solution. So, again, you can get the bonus stuff from online if you cite the sources. But the base level assignment functionality, do not get that stuff from online. You cannot share the assignments or exam questions outside of the course for any reason, including assignment sharing websites or online repos such as GitHub. So I completely realize that this course is online and a lot of people are going to use GitHub to collaborate with their partners. And that's fine. But if you use GitHub, it has to be a private repository, okay? I have a spreadsheet where I have found at least 50 of my assignments on GitHub from previous courses. No, I'd say 40. Yeah, I think 40. I have contacted all of them, and they have all taken them down. Now, there may be a straggler left up there. I have sent DMCA copyright notices to the ones who didn't take it down. I've contacted people on LinkedIn, and they've taken them down. So, I'll come after you. I'm like Liam Neeson about this stuff, right? I'll find whoever's doing it, and I'll get it taken down. Now, I did something. So every offering of every course I've ever done, I've found my code online, either on Chegg or GitHub or whatever. So in 4303, what I did was I am now handing out. So let me back up a little bit. The way my assignments used to be done is that there's a zip file containing the assignment source code. And then I'll go over all this again when the assignments are due. But there was a single zip file that I handed out that had all the files in it. And you just download that, you write the code that I told you to write, and you submit that. However, what I've started doing is look up steganography, if you don't know what this is. But I am now going to hand out individualized links for every single student in the course. And every single file in the zip file that you download will be cryptographically tied to you, the student. It will contain you, your name, your student number, your email address, members of the group, etc. It will have copyright notices. So if you post that online and I find it, even if you delete your names, there is hidden information in those files that you probably won't be able to find that contains your personal information. And so I will be able to find who put it on Chegg, okay? And it will take so many more hours for you to track down and remove all of that information than it will to just do the assignment and not cheat, okay? And you'll see that when you get the assignment. So every single person in the course will be receiving an email to their MUN email address, which is a personalized link to download their assignment files. Okay. Also cheating is reverse engineering any obfuscated solution code that I give to you. So again, I'm going to be giving you pre-compiled solutions for the games so you can see what the game should look like when you've actually completed it, right? So I'm not just going to say, here, go do this. I'm going to give you the Windows executable with my solution so that you can play the game and see what it's supposed to look like. Now, if you try to reverse engineer that, good luck. However, it's going to be a lot less effort to just do the assignment than it will be to reverse engineer assembly code. Someone in the chat just said, I don't know how comfortable I feel about my personal information being shared online. It is not shared online. So let me repeat what is happening. You will be given a secret URL that only you have access to and only you know, and that is where you download your assignment from. Once that assignment is due, that file no longer exists. Inside that zip file, in the files, it'll be your name, your email, and your student number, okay? So your stuff is not posted anywhere online that anyone can access or anyone can see unless you post it online, okay? And there's copyright notices and stuff like that. So let me reiterate, your personal information is only in the files that I give specifically to you and not to anyone else. And that's to prevent you from trying to post it online. Okay, so, and then there's some stuff down here, the legal stuff from MUN that I'm required to put here, but don't worry about that. Okay, cool. So that was the syllabus for the course. If anyone has any questions, feel free to ask those. And now I do have a few slides which are going to go over sort of the actual content for the course itself, rather than just me talking about the syllabus and cheating and all that kind of thing. Okay, so don't cheat. That's that's what I wanted to say. So here we go. Let's. I'm going to switch my scene to the PowerPoint scene, and that all works. Sweet. Haven't done that in 6 months. Glad it still works. So here is the sort of intro slides that will take up, I don't know, maybe a half an hour, maybe less. So intro to game programming. This course is emphasis on the programming. We're going to be doing a lot of programming in this course because I love to beat people over the head with the C++ club. And, you know, beatings will continue until morale improves. If you're not familiar with C++, you will be semi-familiar with it by the time this course is over. Lots and lots of programming, no exams, 5 assignments, and a project. So this course is programming that makes video games possible. So game engine programming, let me get my pen out here. Here we go. Oh, laser pointer. There we go. So game engine programming and gameplay programming. We're going to be using C++ and SFML. And even though I just got off of a big rant about cheating and I seem like an ogre, this course is really fun. I have a lot of fun teaching this course. From the feedback I've gotten, a lot of people have fun taking the course. And you will probably learn a lot in this course unless you're already like an indie game dev or something like that. This course is not a game design course, okay? So people who came into this course thinking that it's a game design course, game design is something completely different from game programming. If you walk into a game studio, like in industry, like an actual building, the game design people and the game programming people are separated. They're in different places in the company, right? They may or may not even talk to each other throughout the course of a day. So game design involves like story writing and coming up with game mechanics, and like there's marketing and all sorts of that kind of thing. That doesn't have anything to do with this course. This course, if you were to look at it as the point of view of the company, is that the game designers and the producers have come to you with the specification for a game, and now your job is to implement that game. And it's also not a Unity tutorial course. So again, we will be doing everything from scratch in C++. The only thing we're not doing from scratch is the loading and displaying of images, because that's a nightmare if you've ever had to do it in C++. So SFML will handle the loading of PNG files and displaying of them to the screen. And we also won't be manually doing input handling. So we are doing input handling for the game, but SFML does things like capturing mouse clicks and capturing keyboard clicks. So that sort of stuff is done for us, but everything else is manual. And some people ask, like, why did I do that? Why not have a game programming course in Unity or in UE4 or something like that? So here was my reasoning for that. A, this is an academic course, and just I don't want to teach you a single game engine, right? So here's the thing. If I taught you Unity, or if I taught you UE4, and you go to a job that doesn't use that exact tool, almost everything I taught you might be useless because it's not Unity. It's not UE4, right? It's not that specific thing. However, if I teach you how to do what Unity does from scratch in C++, then if you go to a company that uses Unity, all you need to do is learn the syntax and where the buttons are, and you're good to go. If you start using UE4, like, you know how the game engine works, and so you know those underlying theoretical concepts, and all you need to do is learn the syntax for that particular engine. So I've done a poll of students in the past, and they have said, so I asked the question to all the students, like, now that the course is over, would you have rather done a game engine from scratch like we did, or would you rather have done a pre-existing engine like Unity or Unreal? And so far, nobody has said that they would have rather done a pre-existing engine. So I think it'll be really fun. So the course structure is Tuesday and Thursday. However, the live lectures have changed. I've already talked about that. There is no mandatory textbook for this course, so the lectures are very important. Some of my lectures, for example, some of the C++ lectures, I may go a little bit over time. Okay, so an hour and 15 minutes is how long each lecture is here officially. However, since there's no textbook, I'm not going to go say read these 3 chapters or whatever. One of my C++ lectures might go, say, 30 minutes over, but it's because I'm trying to give you the best C++ tutorial as possible. So a couple of the lectures may go a little bit over time, but that's fine because we're online and you can view the lectures whenever you want, okay? And I want to have as much content within those lectures as possible so that you can refer to those rather than going out to like Stack Overflow every time and getting information that might be not exactly what I want you to do for the course. I am always available via email. If you send me an email that is class related, just try and put the course title. So like COMP4300 question about this. I usually respond within a day. I am also on my Discord server. So that's Dave's courses server. Please do not share the Discord info with the public. That is a Discord server just for students. And as my former students can attest to, I am online on Discord an unhealthy amount of hours during the day. If you are awake, I'm probably awake on Discord. So just PM me on Discord. However, if you are on Discord, please right-click the server and say set username or set nickname and change it to your real name in the course so I know who I'm talking to, okay? I don't want to be, talking to 420 Blaze It XX, like answering questions about the course. Like put your name there. If you absolutely don't want to use Discord and require voice chat, I can do other things as well. Like you set up a Zoom meeting, I can go there. But PMing me on Discord is usually the quickest way to get a quick response for a quick question. However, if it's something official, like I'm not in the country yet, I have visa problems, etc., please send me an email. I have 2 email addresses. My mun.ca is my official email address. However, I prefer to use my Gmail because the mun stuff is, I won't go in there. But if you want a quicker response, email my Gmail address. Assignments, project. We're going to have 4 total assignments in the course, plus 1 project-related assignment. Assignments are worth 50% of the course. Groups of up to 2, and please don't contact other groups. However, if you have questions, like general questions, please feel free to discuss everything in the course on Discord. So in Discord, there's a 4300 category. There's an announcements channel that only I can post there, so I'll post announcements there. There's also general, talk in general, all you want. Each assignment will be to make a game with a given goal. The course project, the final project is to make a full game. You're going to do a project video trailer or final presentation. Projects will be done in up to groups of up to 2 people. I think I'm going to keep that as 4. What I'm going to do here actually is I'm going to show you something else that I didn't show before. If I go back here to my website, if you go to student project videos and you look at 4300, I have made a playlist of trailers of previous games that were made for the course. Okay, so you can kind of see where and some of these videos are absolutely hilarious. So you can go watch trailers that were made in previous courses, and when you make your trailers, they're going to go onto the website as well. So let's go back. Oops. Where are we? Okay. Yeah, so that's the assignments and the projects. I've already talked about cheating and plagiarism, so I don't need to go over that again. So what is the goal of the course? So the goal, that was weird, the title appeared second. The goal of the course is to learn game programming from scratch in C++. Also, to learn the ECS programming architecture. It's to learn some game programming patterns and software design principles, and to implement several different games. So, I have a little video here, but I'm actually going to get out of there, and I'm just going to show some of the games for the course. So I'm just looking over on my other monitor here. Let me get some of last year's stuff up. So for example, this is assignment 3 in the course. Oops. There we go. This is assignment 3 in the course. It is called Mega Mario. So we are going to be doing from scratch everything that you see here. Okay, so it's Mega Man in Mario Land, collisions, animations, running, jumping, all sorts of stuff. We are also going to be doing, so that's assignment 3. Here's assignment 4. Let's see if I can get my desktop audio running, see if that works. So this is assignment 4. We get into a lot of cool stuff, like, you know, health bars. Like I can take damage in this one. Go up here, look at this, get this health bar. We'll do like teleportation. All sorts of cool stuff. We'll talk about like hitboxes. We'll have these like debug views where we can see all our entities and stuff. Collision boxes, like for example, how did I walk through one of these things but not another thing? Different camera views, all sorts of stuff. And you can see here that this thing is trying to follow me. If I walk over here, oh, these things are following me. This isn't how Zelda works, but whatever. Okay, so that's just, you know, a little taste of what we're going to be doing in the course. All right, so this is another one here. We can talk about like, 1 second. We'll get into like level editing and stuff like that too, where I can actually click and drag things if this video ever plays. There we go. Okay, so here's my mouse, so I can edit the level in real time as it's playing and have the physics interact and stuff. All of this will be trivial for you at the end of this course, okay? Course topics. I already talked about all the course topics, so I don't need to go through those. I want to get into a little bit of ECS. Okay, so what's the plan of the attack for this course? How is it going to work? First, we're going to introduce C++ and SFML starting next lecture. Then, assignment 1 is going to be a very simple C++ and SFML get used to the system sort of thing. So a very simple main game loop. We're going to draw a sprite to the screen. We might play a sound when something happens. And then what we're going to do is we're going to introduce ECS game engine architecture. And then while the course is not over yet, we're going to introduce some new topics and then do an assignment with those topics. Okay? So that's how it works. Pretty much standard for any course. All right, so ECS game programming. I've been saying ECS a lot. What is it? Why do we want to use it? Why does it make our lives so easy when we're talking about game programming? So why are we going to use ECS for games? Well, first of all, ECS stands for entities, components, and systems. So an entity is any object in the game. So for example, you just saw some videos. The player is an entity. A platform is an entity. A tile is an entity. A bullet is an entity. An enemy is an entity. So ECS is actually a software design paradigm. Okay, it's an architecture. It's a paradigm. It can be used for all software, not just games. However, this is a game programming course, so we're going to be using it for games. And in order to understand why we're using ECS, we first have to look back at object-oriented programming and object-oriented design. Well, object-oriented design is a little bit different than object-oriented programming. So in object-oriented design and object-oriented programming, the reason we use object-oriented programming, and you should be familiar with all of this by the time this course rolls around, is it helps us manage our data and our code by using hierarchical structures that reduce brain drain, they reduce the amount of code that you have to use, etc. So an entity is any object in the game. So for example, if we have a bunch of entities over here, let me get my laser pointer. So the player is an entity, a tile is an entity. Each of them are going to share some properties in common. So for example, each entity in the game is going to have an XY position. And so what we can do if we were using the object-oriented approach is we're going to have entity as a base class, and then we might have a tile and a player that inherit from the base class of entity and share some of its properties. So here's what it might look like, okay? So the object-oriented approach might say we're gonna have one base class that's called entity, and then maybe we're going to have, for example, some static entities and some dynamic entities. So static entities and dynamic entities are both gonna inherit from entity. Now, maybe we have like a rock or a tree, right? So if we have a rock or a tree, well, those are static entities. So a tree will inherit from static, which will inherit from entity. Maybe we have a player or an enemy. That's a dynamic thing. It can move around, right? So they're going to inherit from dynamic. But then maybe we have something like an evil tree, which is both an enemy and a tree, but an enemy is dynamic and a tree is static. And so this all breaks down, right? And we'll end up with 1,000 different classes. And object-oriented design like this, it does not work well for larger scale games. So how do entities and components end up helping us with this? So an entity is an object in the game. We've already learned that. A component is a property that we can attach to an entity. So some examples of components might be a position. An entity might have a position. It might have a speed if it's moving. It might have a bounding box if you can collide with it. It might have health. It might have a weapon. It might have damage. So anything, any property that you can think of an entity having is a component. And so what we do then, this entity-component relationship is very important. So a tree, instead of having a base class entity, we're just going to have an entity, right? So there's one entity. And that entity, if for a tree, it's going to have a position and it's going to have a sprite. So we have a sprite component and we have a position component, and we're just going to attach those to the entity that we want to be a tree. For the enemy and the player entities, the enemy, for example, is going to have a position component, an AI component, a sprite component, a bounding box component, and maybe it'll have a velocity component. And a player will only differ from an enemy in the fact that instead of having an AI component, it's going to have an input component, okay? So components, you can think of entities as containers for components. And as we go through the course and we implement this, you'll see that that's exactly what it is. An entity is just a container that holds components. Components hold data, and then the systems are the code that act on the components. So ECS programming, ECS uses composition-based design. So we have components, composition-based design. An entity is any object in the game, so the player, platform, tile, bullet, whatever. A component is a property attached to entities, so again, position, texture, animation, whatever. The important thing is that in ECS, components are pure data. Systems, that's the S, that is the code and the logic that drives behavior. So the movement, the thing that actually updates the position, the rendering, the sound, the physics, those are all systems. So here's some ECS example entity and component relationships. So again, if you have a player, the player could have a position, speed, bounding box, sprite, health, gravity, input. These are all the components that our game would have that we would include in the player entity. An enemy may have some of these things, but instead of input, it would have an AI. A bullet may have various components, and a tile may have various components as well. So how would our systems work? Systems, when we break things down in ECS, systems end up being so simple. Now, they'll be a little bit more complex than this. But for example, the movement system that will update the position of all of our entities in the game can be really simple, like this. And this is almost the exact C++ code that we'll actually see when we get into the assignment. So for each entity, so for E in entities, add the velocity of the entity to the position. And that's how all of our entities move. That's it. One line of code to move all of our entities in the game. How about our collision system? So say, for example, we want to do the collisions between bullets and enemies. So we can say, okay, for each bullet in the game, we're going to loop over each bullet. For each bullet, we'll check to see if it hit each enemy. So we'll call our physics system and say, if there's a collision between the bullet and the enemy, then the enemy's health is going to be reduced by the bullet's damage, and then we're going to destroy the bullet. Simple. And if you wanted to make a bullet that passed through enemies, well, you just would not destroy the bullet. Also, for our rendering system, that's going to be super simple as well. Just for each entity in our game, draw the entity's sprite. That's it. So these are like a little bit simpler than what we'll see in actual games, but the point is that we're going to be looping over our entities, grabbing the components that we need to work with, and then doing something to update those values within our systems. So that's ECS in a nutshell. So the architecture for the engine that we will be building in this course, and we'll go down into all the details of this as we go along, we're going to have a main game engine class, okay? Now, just because I said that we're not using object-oriented design for our objects in the game doesn't mean we won't be using object-oriented programming to implement ECS. ECS pairs really, really well with object-oriented programming. So object-oriented design is different from object-oriented programming, so we will be using the ECS architecture with OOP to implement that architecture. So we'll have a game engine class. That game engine class will store a number of scenes. And scenes, for example, you might have a menu scene, you might have an inventory scene, you might have a gameplay scene. So those are sort of the states of the game that you're currently interacting with. Each scene will have its own systems. So for example, a menu might have a system that moves the cursor up and down. Gameplay will have systems that say move Mario or let him shoot. And then each scene will also have an entity manager, which handles the creation and deletion of all of our entities. And then each entity will be essentially a container for component data. So this is the overall architecture for the engine that we'll be building in this course. And this architecture is a balance between efficiency and usability, okay? So we'll be making things as efficient and as fast as possible when we go through the course. However, as we learn things at first, we're going to be doing things a little bit slower to catch you up to speed, like less efficient implementation. And then toward the end of the course, we're going to take those lower efficiency implementations that were done in order to let you learn an easier way of doing it at first. And I'll say, okay, if we were making an actual game for industry, here's all the optimizations that you would go apply to that architecture in order to make it as fast as possible. So we'll have, I'm not going to go over this yet because we'll go over this in a few slides, but we'll have like a game engine which stores scenes. A scene is going to have an entity manager. Entities are going to store components. Components are essentially an interface, and we'll have subcomponents, which things like transform, which stores position, speed, scale. We might have health, etc. We'll also be talking about things like asset loading and storage. We'll be talking about physics. We'll be talking about game vectors and game math and all that sort of thing. And we'll go through all of that in later lectures. Okay, so let me go quickly back here. So that was the first lecture in the course. And so here we are September 9th on a Thursday. So I have to go give another lecture now, but this evening, you will see that all of these links update with the VOD to this Twitch broadcast, and also the YouTube video and the link to download this video. So that's it for this lecture for 4300. I hope you all are excited about this course, because I'm super happy and super excited to be teaching it. I love programming. I love C++. I love games. So this course is just like a dream come true for me to be able to teach. Now, this will not be true of all classes for this. Normally what I would do last year is I would go host somebody and you could go to their Twitch channel and watch it. However, for today, remember that the next live lecture for this class is on Monday. Okay, so if I go to my schedule for the course, so if you go to my schedule here on Twitch, you can see that this is the class today at 3:30 today. So in a half an hour is my 3:30 today. So in a half that was me not muting my own channel as I'm watching it. So at 3:30 in a half an hour is my Intro to AI course. So people from 3200, maybe some of you are also taking 3200, are going to be back here looking at that. And you can also see, if you go to the future weeks, this is the schedule for streaming these courses live. However, the videos will still be there, and you can watch the videos for this course whenever you want. Okay, so the live lectures for this class, 4300 only, are moving to evenings on Mondays and Wednesdays. So the evening before Tuesday and Thursday at 7 p.m. is when the live lectures for this class will be. But the standard 2 p.m. time, all of the videos will be here for you to watch. Someone just asked, no way to get students for assignments for non-students. Nope, the assignments are never going to be given out to non-students for this course. However, what I might do is I might give out like some of the skeleton code that lets you just set up and run a game, because I know people want to play around with that who aren't in the course. Okay, so I may give out sort of like a dummy assignment that's not for the course, but stay tuned for that. And if I do, I'll link it here somewhere. But I can't promise that that will be anytime soon. This one more thing is that the lectures will be here linked on this YouTube playlist. This link doesn't exist yet, but it will as soon as this is over. Okay, so that's it for this class. Thank you all for watching.